Hello, this is the experiment of compressive strengths of concrete, of cylindrical concrete specimens. The ASTM designation for of this experiment is ASTM-C39. We call it compressive strengths of cylindrical concrete specimens. And the purpose of this experiment is to determine the compressive strengths of cylindrical Portland cement concrete specimen, such as molded cylinders, and drilled cores. So this is the main, and also the main, as we said many times, for anything related to the compressive strengths of concrete, the main purpose actually is to have, or the main significance as well, is to have a kind of quality assurance measure. So this is the main purpose and significance and use of the experiments in general. For the significance and use, this test provides the compressive strength of concrete, which is used universally as a measure of concrete quality, as we have mentioned before. The apparatus that is going to be used, we are going to use the loading machine with two hardened steel braking blocks. The upper block is spherically seated and the bottom block is solid surface, as seen in this figure here. Let me zoom out a little bit so that we can see. As you can see, this is the top part and the bottom part, and this is, maybe the UTM machine is different a little bit in your lab than what you are seeing here, but at the end we are having the same setup, kind of cylinder from the top and a seat or metal seat on the bottom, and then loading is going to be applied by a kind of unit, CPU unit outside or computer outside. Okay, now let's go to the test specimens. As we have mentioned before, test specimen, the standard specimen size used to determine the compressive strength of concrete is 152 millimeter, 6-inch diameter by 304 millimeter, which is 12-inch diameter. So it is 6 by inch diameter. Height, this is the height, okay, 6-inch diameter and 12-inch height for a maximum aggregate size of 50 millimeter, 2 inches, as we said it before. Smaller specimens such as 4-inch by 8-inch high are sometimes used, but remember well, they are not ASTM standardized. Okay, so we should use our 12 or 6 by 12-inch diameter and height. Conduct the compression test on the moist cured specimen. Take care of this. It should be moist cured specimen directly after removing them from curing room. Test specimens must be moist when tested. It must be moist. Okay, it should not be dry. After that, neither end of compressive test specimen shall depart from perpendicularity by more than 0.5 degree, approximately 3 millimeters and 0.3 meter, 1/8 inch and 12 inches. Okay, the main point here is the perpendicularity. Take care of it. Okay, if the ends of the specimens are not plane within 0.05 millimeter, which is 0.002 inches, they should be capped with sulfur or capping compound. Neoprene caps may be used. Okay, as you can see in figure A39, this is neoprene caps used for capping a concrete cylinder. Let's zoom out here. This is, as you can see, top and the bottom, okay, caps. Okay, but they are not ASTM standards. So if you are going to use these caps, they are not ASTM standards. Specimen age at time of testing should be 24 hours plus or minus 0.5 hours, 3 days plus or minus 2 hours, 7 days plus or minus 6 hours, 28 days plus or minus 20 hours, or 90 days plus or minus 2 days. These are the specimens ages. Try to keep them as much as you can. Let's go to the test procedure. They are easy actually. They are like 8 points. We're going to go through them. So first of all, we are going to measure the diameter of the test specimen to the nearest 0.25 millimeter by averaging the two diameters measured at right angles to each other at the middle height of the specimen. This is important just to ensure that the diameter of the specimen is like okay. Adjust the bearing blocks into position. That's important. Clean the faces of the bearing blocks and specimen. Number 4, carefully align the axis of the specimen with the center of the thrust of the spherically seated block, which is the bottom one. Okay. Apply the load continuously and without shock. For screw-type machines, use a rate of loading of 1.25 millimeter per minute, which equals to 0.05 inch per minute. For hydraulically operated machines, apply the load at constant rate within the range of 138 kilopascal per second to 335 kilopascal per second. Okay. During the first half of the anticipated loading phase, a higher rate of loading is permitted. No adjustment in the control of the testing machine should be made while the specimen is yielding rapidly immediately before failure. This is an important. So you need to keep or try to lead the machine or the rate as it is without any kind of modifications whenever that the rate goes beyond half of the expected or anticipated failure loading. After that, continue applying the load until the specimen fails. Record the maximum load carried by the specimen during the test. This is an important issue because you need to know the maximum load. And number 8, note the type of failure and the appearance of concrete. Let's go and see what is the type of failure as it can be shown here. We have like 6 main types of failure. If you can see, let's zoom out, yes, here. So we have like the first type, which we call it cones on both ends. As you can see, cones on both ends. So we're going to find clear cones on top and bottom. And the second one, it is cones on one end. As you can see, this is a cone on one end and vertical cracks on the other. Vertical cracks. These are vertical cracks as you can see it. Number 3, it is vertical cracks only. You cannot distinguish any cones here. Number 4, you are going to find diagonal fracture. We call it diagonal fracture. As you can see, 5, side fracture, one part. And 6, it is going to be side fracture. Sorry, this is side fracture from here and here. Side fractures with pointed ends. We call it, this is the analysis and results. We are going to calculate the compressive strength as F prime C equal to P maximum over A, where F prime C equal to the compressive strength in megapascal, P maximum, which is the maximum applied load in Newton, A cross-sectional area in millimeters squared, and we are going to report at the end specimen identification number, diameter, and length if outside the range of 1.8 to 2.2 times the diameter, cross-sectional area, maximum load, compressive strength calculated to the nearest 0.07 megapascal, type of failure if other than the usual one, defects in either specimen or caps, and age of the specimen. This concludes our experiment for today. Thank you.